everyone, and welcome to the very first episode of this coding tutorial series. This series will teach you how to code Beck's robots using C++. C++ is a programming language that is used by lots of people. This first episode will be getting us some background knowledge on C++, so if you already know about C++ and you feel like you already know some of its ins and outs, then feel free to skip this episode and move on to the next one. For those of you sticking around, let's get started. Alright, so C++ is a text-based programming language. This means that C++ doesn't use blocks, and it instead uses text. Alright, so during coding, you're going to have lots of errors. In fact, you're probably going to spend a lot of time debugging errors. So it's nice to know what the different types of errors are so you can more easily identify your errors and know how to solve them. The first type of error is the most common error, which is a syntax error. Syntax errors occur when something is written incorrectly and the computer can't understand it. Currently, all this code is written correctly, but if I were to just delete a couple letters, the computer now doesn't really know what's happening, so it says, hey, you wrote this wrong, underlines it, and it'll say that we have a problem. Furthermore, if you try to download code of a syntax error, the compiler will stop you and say, hey, there's an error, fix your code. So that is what makes syntax errors so nice and easy to fix, because it tells you exactly where the error is. It'll say, hey, on line 68, you did something wrong. Sometimes it'll even kind of tell you what you did wrong, which is very nice. The most common type of syntax error is forgetting these little semicolons here. If you forget one of these semicolons, as you can see, it creates an error. Now, these semicolons are used in C++ to separate different lines of code. In other coding languages, you would just have the codes on different lines, but in C++, we use semicolons. Now, this does mean that I could, if I wanted to, write the code all horizontally. As long as it's separated. As long as each line is separated by a semicolon, this won't make any errors. But that's a bit messy to look at, so it's a little bit easier to just have it vertical. The next type of error that we'll be talking about is also pretty common, a logic error. Now, logic errors occur when everything's right with your code, you run your code, but it does something that you didn't want it to do. Like, let's say it spins a motor backwards, or it doesn't move forwards far enough. Those are just two examples of different types of logic errors. Logic errors can be pretty easy to fix. As long as you can identify what the robot did wrong, then you can fix the logic error. Now, the third type of error, and the most rarest error, is a runtime error. Now, runtime errors are a bit tricky and will essentially occur whenever your code crashes. So, for example, right here, I have the robot spinning motors forwards for 120 degrees. But if instead of telling it to go forwards 120 degrees, if I tell it to go forwards 120 divided by 0 degrees, once the robot tries to do this, it won't know what to do, and the code will crash, causing a runtime error. Now, runtime errors, as you can see, it doesn't tell you that you made an error here. But also, I've never run into a runtime error because they're pretty hard to make happen. So just be smart, don't divide things by 0 or make your robot do other things that will cause it to crash, and you should be all good. The next thing we're going to talk about is variables. Now, variables are very important as they allow you to change different things in your code. There are 6 different types of variables in C++, but for coding robots, we mainly only use 4 of them. The first type of variable is an integer variable. Now, when you want to use this in your code, you would simply write int. Now, an integer variable can store any whole number. So it can store 1, it can store 10, it can store 5,689. As long as it's a whole number, the integer variable will store it. The next type of variable is a float variable. Now, to use this in your code, you would write the word float. The float variable stores any number with up to 7 decimal places. So you could have like 5.6, 1.23, just any number at all with up to 7 decimal places. Now, if 7 decimal places isn't enough for you, then that's when the double variable comes in. The double variable can store any number with up to 15 decimal places, and to use that in your code, you just write the word double. Now, the last type of variable that we use commonly in robotics is Boolean variables, which when written in your code, are just written as bool. Boolean variables store true and false values. The other two types of variables aren't used as much in robotics, but I'm still going to put them here in case you really need to use one. So the other two types of variables are character variables and string variables. You use them by writing char and string in your code. The character variable stores a single character, and the string variable stores text. Now, these aren't used that much in robotics because we're usually mainly dealing with numbers and trues and falses, not so much words. But, I don't know, maybe it's still helpful to know. Next thing that we're going to be talking about is functions. Now, functions are a very useful part of coding, and they can allow you to make your code more neat, more concise, and more easy to read. And functions essentially have two main purposes, which is shortening code and making it less lines, and making repeated code that you write often much more easy to deal with. Now, there are different types of functions. You can have functions with parameters or without parameters, and functions with return values and without return values. Return values, although they are sometimes used, they aren't used too commonly, so we're just going to ignore those for now. We're going to focus on functions with parameters and without parameters. So a parameter is essentially just a custom value that you can change in your function. So for example, if I had a function that made my robot go forwards, a parameter could be how far forwards it goes. A function without parameters will just do the same thing each time. So let's say you wanted a catapult to move a certain distance and then reset itself, you'd use a function without parameters. So let's put that into action really quick. Alright. So let's say we have this nice little robot, okay? This robot has 4 motors and has 4 wheels. Now, if we want to get this robot to move forwards, that's going to require 4 lines of code, as shown here. Now, you don't really know how this code works quite yet, and that's okay. You don't need to for this. This is just kind of me showing you that using functions can make your code simpler. We'll worry more about what all this does and how to code stuff in episode 4. So you'll have one for each motor to spin forwards for 120 degrees, just for example. Let's say that you decided, actually, I need to move this robot 130 degrees. Now you have to go through and edit all 4 of those lines. And then let's say you want to have it go forwards again. Now you have to write out 4 more lines. But with functions, there's a quicker way to do this. Instead of having to write out the same thing over and over again, we can just write it out once in a function. So for example, this function is called spin all, and it has parameters, which are things that can be changed. And the parameters in this example are the direction type and an integer, and the integer is called spin amount. So to explain what's going on here, we have told the function that we're going to be using the words dir, which is a direction type, and the word spin amount, which is an integer. Then we wrote in our code, and whenever we wanted it to have a changeable direction, we wrote the word dir, and a changeable spin amount, we wrote the word spin amount. So when we call the function, which is a fancy way of saying use the actual function in the code, we will write it with a direction and a spin amount. And then if we write that one line of code, it will run all 4 of those lines of code with our chosen direction and our chosen spin amount. Now that means that we could replace all of these lines of code with just one line of code. So the code at the top is called a function definition, and it is the code that defines what the function does. At the bottom, we have just like the function call, which will call the function with the values that we give it. And now if we ran this code, it would spin all 4 motors forwards for 110 degrees. Which is a lot easier than writing out 4 lines of code for each time we want to move the robot forwards. Furthermore, if we needed to make the robot go more forwards, we could change it really quick and really easy. Or if we needed the robot to go backwards, really quick and really easy change. A use for a function without a parameter is controller buttons, because when you click a button, you want it to do the same thing every time. So you use a function without parameters. For example, let's say you just want to make a button have the intake move forwards. You want that to do the same thing every time, so you just make a function, and instead of giving it parameters, you just type in the word void. That concludes this coding episode. Hope you enjoyed this coding episode. I'll catch you in the next one.